Hi everyone, welcome back to sisyaclass YouTube channel. So today we are going to talk about equilibrium. So I hope you are following the EAPCET series, you have solved questions based on the last chapter also. Today also we are going to discuss physical chemistry. We are going to understand the concepts, then we will solve questions based on them. And I personally like physical chemistry, so you will find this chapter very interesting. So before we start, I have a small information for you. Then we are going to begin with our content for today. Okay, so let's begin, everyone. Yes. Okay. So I hope you have downloaded our app, but if you have not, we have a offer for you. We are starting with a new maths course for grade 3 to 10 at just ₹999. In that course, you can cover your entire CBSE, your ICSE and state board syllabus. All IIT and NIT teachers will be teaching you. And if you have downloaded the app, you already know about Sysya AI, in which you can ask your doubts. Text-to-text doubt solving, speech-to-text doubt solving, image-to-text doubt solving is also available for you. So don't miss this chance. Please enroll in this course. It will start from 5th May. Okay? So this was one small piece of information that I wanted to give you. Now let's begin with our content. Okay? So I will just introduce myself. Then we are going to see what are the topics we will discuss today. And then we will solve questions based on them, as we have been doing in a lot of other sessions before. I hope you are following that. Okay? So let's start. So my name is Nidhi Narwal. I have done my post-graduation from IIT Bhubaneswar. I have 6+ years of teaching experience and I have taught these IIT, NIT competitive examinations. IIT and your NEET, JEE Mains competitive examination. And if you are following me, you already know about that. So let's begin with our topic today. Alright, so what are we going to discuss today? We are talking about equilibrium, right? So we will talk about equilibrium constant, right? How do we convert that? If you are given with the equation, let's say there is some equation in which equilibrium constant is given to you. They reverse the equation, they add two equations, they subtract two equations. How do we understand what is the final equilibrium constant? Such simple easy peasy questions are also asked. So we will cover that, okay? So we are going to talk about the law of mass section. How do we represent equilibrium constant? What do we mean by Kp? What do we mean by Kc? What is the relationship between Kp and Kc? We will see that. Okay. So equilibrium constant, Kp and Kc. Okay. What after that? We are going to see the factors affecting equilibrium, right? Let's say your equilibrium is established, right? Le-Chatelier's principle. I hope you are aware of that. We will solve questions based on it. Very important, very interesting, and you don't have to solve much if you know the concept. So we will understand if you have an established equilibrium, you try to disturb it, how will the equilibrium respond to that? We will learn that, okay? Then different types of acid-base theories and how do we understand pH of acids, pOH of bases, or maybe pH, depends upon the question, okay? Then we are going to learn about common ion effect and salt hydrolysis, right? So very interesting, very important topics we will cover today. Again, since numericals are involved, we are not going to solve it to the completion part. We are going to understand the concept. After that, you have to substitute the values as we have been doing in other physical chemistry chapters also. I hope you are aware, okay? So these are the major chunk of the topics we will cover today, and if we see any numerical and something new is asked there, we will cover the content of that question also. So don't worry, whatever numerical we see, whatever question we see, if there is some concept involved in that question, I will explain that first, then we will solve question. Okay, so let's start with the content now. Let's start with important points of equilibrium. Okay, let's start. Okay, so first of all, we should know about law of mass section. So let's say this is your equation. Where A and B are your reactants, C and D are your products, small a, small b, stoichiometric coefficient, small c, small d, stoichiometric coefficient. Okay, so this equation is given to you and they are asking you, can you write the equation for equilibrium constant? Yes, we can. How? the equilibrium constant, since we are considering the concentration of reactants and products, we have written Kc. If you consider the partial pressure of reactants and products, you will call it as Kp. Okay, that is the only difference. Equilibrium constant can be represented in terms of concentration. Equilibrium constant can be represented in terms of moles also. We are not covering that, but you can write the equation in terms of number of moles also. What we are concerned with, Kp and Kc. If you write the expression for equilibrium constant in terms of partial pressure of reactants and products, Kp. If you are writing the equilibrium expression in terms of concentration of reactants and products, we will call it as Kc. But it is an equilibrium constant. Don't get confused there. Okay. So this is the equilibrium constant in terms of concentration of reactants and products. How do we write it? In the numerator, you will write the product concentration raised to their stoichiometric power. What I have said? In the numerator, you will write the product of concentration of products raised to their stoichiometric power. Okay, so your product is C and D, right? So I will write their concentration, multiply them. What will be their powers? Their stoichiometric coefficient. So we have to balance the equation. Yes, you must. Okay, so stoichiometric power of C, stoichiometric power of D. This is in the numerator. What should we write in that denominator? Reactants. So concentration of reactants raised to their stoichiometric power, and you are done. That is the equation for your equilibrium constant. Do we have to include something that is in pure solid, that is in pure liquid state? No. You have to include only aqueous ions. Pure solids and pure liquids are not part of your equilibrium expression. What I have said, note it down. Pure solids and pure liquids are not considered in your equilibrium expression. We consider their activity to be 1. So we don't have to substitute it. We don't even have to write it. Forget about them. If you see any equation in which pure solids and pure liquids are given there, don't include them in your equation itself. They will not change your equilibrium expression. Okay. See, we have written that here also. Pure solids and liquids are not included. Important. So this is the equilibrium constant in terms of concentration. If you write the equilibrium constant in terms of partial pressure, we can do that also, right? Please see, AP, equilibrium constant in terms of partial pressure. Nothing fancy, same thing. In the numerator, you will have the partial pressure of products divided by partial pressure of reactants. Okay. Same thing, exactly same thing we have to do here. Okay, just we have changed the concentration with partial pressure. Now we are going to call it as Kp. This was Kc. So equilibrium constant in terms of concentration Kc, equilibrium constant in terms of partial pressure Kp. Okay, so this is the first thing. Now what else? And one more thing, these concentration that you have written, these are not just random concentration that are given to you in the reaction at the beginning or at the end of the reaction. No, these are the concentration at equilibrium. At equilibrium, what is the concentration of all the reactants and products? Those values you have to substitute here, not some random values. Very, very important. Okay, so this is at equilibrium. What if we write the values of concentration of reactant and product at some other point in the reaction? You can do that. What will you call it then? You will call it as reaction quotient, not equilibrium constant. You will call it as reaction quotient. We denote it by capital Q. We will see that also. Okay, so the expression looks similar, but there you can substitute any values. If you are talking about the equilibrium part, then you will call it as equilibrium constant. That is the only difference. We will cover that once again when we will talk about reaction quotient. Okay, see the next thing. Relationship between Kp and Kc important. Very simple, easy peasy kind of question can be asked from you. So let's say they give you the equilibrium constant in terms of concentration. Kc is given. They will ask you about Kp. Kp is given, they will ask you about Kc. So you should know the relationship between the two. Very simple. Kp equal to Kc, RT raised to the power delta n. What is this delta n? You have used this delta n in the last chapter also, if you remember. When we were talking about thermodynamics, we have calculated delta Ng. You have calculated the enthalpy value, remember? Delta H is equal to delta U plus delta Ng RT. You have done that in last session. So that same delta Ng we are talking about, it is not a new phenomena. It is the same delta N. Okay, you want to write it as delta N or delta Ng, up to you. It means the same thing. And how do we calculate delta Ng? Moles of gaseous products minus moles of gaseous reactants. Again, we don't have to include pure solids and pure liquids. You just have to include gaseous reactants and products. That is all. Please don't include anything that is pure solid or liquid. That will not give you delta Ng. Okay, that is why I've written the small g there, so that you can remember we are talking about gases. We are not concerned with pure solids and liquids. Okay, so this is done. Kp equal to Kc, RT raised to the power delta Ng. We will solve questions also on the basis of this expression. Okay, this is done. What else? Reaction question. This is the reaction question I was talking about. So you can write the expression for a chemical reaction at any point of time. You can write the same expression as what you have written for equilibrium constant. What is the difference? In this case, the concentration is at equilibrium. That is not a mandatory part. Okay, you can write any concentration now. You will call it as reaction question. Why are we going to write the expression for reaction question? What are we trying to determine here? You are trying to see the direction of reaction. Okay, so at any point of time, you will find out the value of reaction question, and by seeing that value and comparing it with equilibrium constant, you will come to know whether we are at equilibrium, whether we are going to move in forward direction, whether the reaction will go in backward direction. You can decide it, and that is how the question also will be asked. Okay, so they will give you the different concentration of reactants and products. They will give you the equilibrium constant also in the question. They will ask you to calculate the reaction question, and based on the value that you calculate for reaction question, you have to decide in which direction the reaction will proceed. That is how they will ask the question. Not at all difficult. Okay, so please see, if your reaction question is less than, this is equilibrium constant, everyone. Okay, I have just written K here because it could be Kp or Kc, does not matter. It should be a equilibrium constant. So if your reaction quotient is less than equilibrium constant, then we will say the reaction will move forward. Forward direction will be seen in the reaction. This is how you have to answer. What if your reaction quotient comes out to be equal to equilibrium constant? Then you will say we are at equilibrium. We are already at equilibrium, as simple as that. Okay, so if both of them are same, you are at equilibrium. What if your reaction quotient is more than equilibrium constant? Then the reaction will move backward. Reaction will proceed in backward direction. So you have to remember these three things. And for that, you have to know how to calculate the reaction quotient. Not at all different from equilibrium constant expression. Only difference is here you can take the concentration and partial pressure of reactants and products at any point of time in the reaction, whatever is given in the question. If you substitute the values at equilibrium, it will become a equilibrium constant. As simple as that. Okay, so what is the importance of calculating reaction quotient? You can decide the direction of your reaction. Okay, see the next thing. Now, Le Chatelier's principle, again very important. Already the equilibrium is established. Okay, so far we were talking about this is how equilibrium will be established. This will be the concentration of reactants and products. Now we are saying that the equilibrium has been established. Now you try to disturb it. How can we disturb the equilibrium? Maybe you add some more reactants, maybe you remove reactants, maybe you add products, maybe you remove products, maybe you increase pressure, maybe you decrease volume. So many things you can do to disturb the reaction. Now, when you disturb the reaction at equilibrium, what is the response of your equilibrium reaction? It will try to negate any change that you have done. It will try to come back to its original position to avoid the disturbance. So in order to do that, maybe if you try to increase the concentration of reactant, reaction will do the reverse. It will try to decrease it. The reaction will try to attain the equilibrium once again. It does not want any more reactant. It does not want any more product. So whatever disturbance you create, reaction will try to negate it. And in order to do so, in which direction the reaction will move can be asked in the question. That is the idea behind Le Chatelier's principle. So don't stress too much about the exact definition. Now you know the crux. No one is interested in knowing the exact explanation of Le Chatelier's principle. They are interested in knowing whether you know in which direction the reaction will proceed if you do the disturbance. Okay, same thing we have written here. When a system is at equilibrium and you disturb it, it shifts to minimize the disturbance. It will try to negate any disturbance that we have created to the reaction. It will try to re-establish the equilibrium, and in order to do so, you have to know in which direction the reaction will proceed. So we have a small table for you. Note it down, take a screenshot and memorize it. It is very, very important. Direct questions will be asked and we will solve such questions. Okay, please see the table. See, if you increase the reactant concentration, this is the change that we have done. Equilibrium was established, you tried to disturb it. How you try to disturb it? You increase the concentration of reactant. How will the reaction respond to that? Reaction will try to reverse the change. You increase it, reaction will try to decrease it. How will the reaction decrease the concentration of reactant? By moving in forward direction. That is how it will consume the extra reactant that you have added. Please see. It shifts forward. Do we have to cram this information? No. You have made the changes to the equilibrium reaction. What is the change you have done? You increased the reactant concentration. We already know reaction does not want that change. Reaction will try to decrease it now. How will the reaction decrease the reactant concentration? By going in forward direction. What if you increase the product concentration? How will the reaction respond to that? We increase the product concentration, reaction tries to decrease it. How will the reaction decrease the product concentration? By going in backward direction, and your question is over. Okay, so if you increase the product concentration, your reaction will shift backward. So I hope you understand we can do the reverse also. What if they ask you about reacting concentration is decrease? What should we do now? You will move in backward direction. So that second part, I am thinking that you already know that. You can do the second part and you should know that. Okay, I will write one example, but after that you should know. Reactant concentration, what if we decrease it? So here reaction will try to increase the reactant concentration. How will the reaction do that? By going in backward direction. Okay, so like that you can add the product concentration also. Simple, easy peasy, do the reverse. Okay, what else we can do? We can increase pressure, which will have the exact same effect as decrease in volume. So if you understand the change in pressure, you yourself know the change in volume also. Pressure and volume are inversely related to each other. Boyle's law, you have learned that in states of it. Okay, so if you increase pressure, reaction will shift in that direction where lesser number of gaseous moles are there. Why? Because it wants to decrease pressure. Please see. It will shift to that side which has fewer gases, because fewer gases will exert less amount of pressure. You increase the pressure, reaction tries to decrease it. You decrease pressure, reaction will try to increase it. Will move in that direction where you have more number of gaseous moles. What if you decrease pressure? Reaction moves towards more number of gaseous moles. See, I am not cramming this table. You don't have to cram it. If you understand this part, you can easily write the rest of the things also, but you have to think first. You have to write the equation, try to understand what we are doing here. We are creating some disturbance. What is the reaction doing? Doing the reverse. Reaction tries to negate the disturbance. It wants to establish the equilibrium once again. So whatever you do, the reaction will try to do the reverse, and accordingly you will decide in which direction we have to move. Okay. Now, what if you increase temperature? Now, increase in temperature is very, very important because there are two cases. Whether the reaction is endothermic or exothermic will decide it for you. Okay. So if you increase the temperature and it is an endothermic reaction, you will go in forward direction. I will write this here. You are increasing the temperature for an endothermic reaction, move forward. And in the same scenario, if you are talking about an exothermic reaction, reaction moves backward. So will it tell us whether the reaction is exothermic or endothermic? Yes, will be given in the question, so you don't have to worry. So if your reaction is exothermic, they increase the temperature, go in backward direction. If your reaction is endothermic, they increase the temperature, go in forward direction. Okay, so this is what I have written here. Increase in temperature for exothermic reaction, reaction goes backward. For endothermic reaction, it will go forward. So the type of reaction will decide in which direction you have to move. Okay, what if you add some catalyst? There will be no effect on the equilibrium position. Your catalyst will not affect your equilibrium constant. It will increase the rate of forward as well as backward reaction by equal amount. So there will be no net change if you add some catalyst. What if we add some inert gas? No change in that scenario also, provided you are adding the gas at constant volume. So at constant volume, if you add the inert gas, no change. Okay, so these are the different changes that you can introduce in your chemical reaction, and this is how your system will respond. This is how your reaction will respond. So you should know this tip. Okay, again, extremely important, and direct questions will be asked from this part for sure. Okay, see the next part. Acid-base equilibrium, Arrhenius plus Bronsted-Lowry expression. Okay, so you know about Ka, dissociation constant of acid, Kb, dissociation constant of base, Kw, ionic product of water. So this is the expression. Ka into Kb is equal to Kw, and at room temperature only. Kw has a fixed value at 25 degrees Celsius only. At some other temperature, the value may change. So don't always think that Kw is fixed 10 to the power minus 14. At room temperature, it is fixed. But if you change the temperature, your Kw value can also change. Okay? So this is only true at room temperature. Not at all temperatures, you will write it as 10 to the power minus 14. Please don't do that. Okay? Now, Ka, acid dissociation constant, already done. Base dissociation constant, and this is ionic product of water. And this value 14, pH plus POH is equal to 14. This is only true at room temperature, obviously, because at room temperature only we are saying that Kw is equal to 10 to the power minus 14, right? This is also true at 25 degrees Celsius. At some other temperature, your Kw value will change. Based on that Kw value, you will decide what will be the sum of pH plus POH. Okay? Now, see the next thing. Now, this is your salt hydrolysis, and how will you calculate the pH for that? And please, please, please memorize this table. Very important. Okay? So, weak acid plus strong base, pH is 7 plus half of log of Kb over K will be given in the question, Kb and K. You just have to remember the expression. So please note them down, and based on the salt type, you will decide the formula for pH. Okay, these questions are not asked repeatedly. Okay, maybe one time they will ask you the pH of the salt that is formed with a weak base and a strong acid, like that. Very rarely one question you can expect, not more than that. Okay, but yes, you should be aware of the formula at least, because sometimes they ask you the formula directly. So we should be prepared. Now the examiner wants to ask us something fancy, we can easily understand based on it. Okay, see the next part. Buffer solution. So you can have acidic buffer, basic buffer. Based on the type of buffer, you have to calculate the pH. Again, can be asked directly. How you are preparing buffer also, that is also a potential question, and how do we calculate the pH of that buffer solution. So please remember the formula. This is important. Okay, that salt hydrolysis one, you can go through it, but not that important, so you can skip it also. But this one, please don't skip it. You have to memorize it. Okay. So for acidic buffer, pH is equal to pK. K, acid dissociation constant, minus log of K is pK. Minus log of Kb. So you already know these basic formulas. I am not repeating them. I am just writing it at one place. You already know about them. Okay. So pH is pK plus log of concentration of salt over acid. Since we are talking about acidic buffer, how do we prepare acidic buffer? Weak acid plus salt of its conjugate base. If you mix them in 1:1 ratio, this will make acidic buffer. Similarly, if you take a weak base and you add the salt of its conjugate acid, we understand the concept of conjugate base and conjugate acid. Can be asked, what is conjugate base? If you are given some acid, you remove a proton from it, one single proton. Then the anion that you receive, what do we call it? Conjugate base. For example, you have acetic acid. If I remove a proton from here, this proton I have removed, what do we call this acetate ion? Conjugate base of this acid. So how do we form a conjugate base of something? Remove a proton. How do we form conjugate acid of something? Add a proton. This is your base. I have added a proton to it. I get ammonium ion. What do we call that ammonium ion? Conjugate acid of ammonia. So you want to form conjugate base of something, remove a proton. You want to form conjugate acid of something, add a proton, like that. Okay. So I hope we get these terms. Conjugate acid and conjugate base can be asked to you. They will give you some acid or base. They will ask you what is its conjugate acid, what is its conjugate base. That is all you have to do. If they ask you conjugate base, remove a proton. If they ask you conjugate acid, add a proton. One single proton, nothing more than that. Okay. So this is how you calculate the pH of or pH of acid and basic buffer respectively. Okay. Now, solubility product, the last part. For example, you have this kind of salt. It dissociates to give you Ag positive and Cl minus ion. You want to represent the expression for Ksp for this salt AgCl. So you will write Ksp of AgCl is product of concentration of ions that you have found. Okay. So concentration of Ag positive, cation and anion. What if they have some stoichiometric coefficient? What if some more ions are produced? They will become the power. Okay. So like that you can write the expression for Ksp, and we can use Ksp to compare solubilities. If your reaction question comes out to be more than Ksp, such questions are asked. Okay. They will give you the value of Ksp in the question, reaction quotient, you will calculate for that question based on the values given, and based on the comparison you will decide whether the precipitation is possible or not. Okay, so if your reaction quotient comes out to be more than Ksp, you will say precipitation is possible. If it is less than that, you will say precipitation is not possible. Okay, so this is the content that you have to know. Now based on this we will solve questions. Okay. Alright, so we have covered the major chunk. We have talked about buffers, we have understood the concept of acids and bases, we have talked about equilibrium constant, we have learned about pH of the solution, and then we have talked about solubility product also. Now let's start with our questions. Okay, let's begin. At 300 Kelvin, the Kc for the reaction is 100 mole per liter. Okay, so Kc is given to us 100 mole per liter. Great. What is the Kp in atmosphere at the same temperature? Now, do we remember the relationship between Kp and Kc? I hope you all remember it. We have just learnt about it, and this is how the question will be asked. Okay, so this was asked last year. What is the relationship between Kp and Kc? Kp is equal to Kc into RT raised to the power delta Ng, and done. Okay, please write. Kp is Kc into RT raised to the power delta Ng. What is delta Ng? See, the equation is also given to you. Let's calculate delta Ng. Number of gaseous moles on the product side, 1 gaseous mole, 2 gaseous mole, minus 1 gaseous mole on the reactant side. So 2 minus 1. Substitute that value. 100. What is the value of R? See, they have given you in the question also 0.082, and otherwise also, since they are asking you the answer in atmosphere, obviously we will use which value of R? All those who are following the sessions, they already know we have 3 values of R that we choose based on the question. So in here, since we are talking about the answer in terms of atmosphere, we will choose which value of R? 0.0821 liter atmosphere per Kelvin per mole. Always remember the value of R along with the unit. Please don't memorize just the values and forget about the units, because it will not make any sense and you will solve it incorrectly. Always remember the units, substitute it, you will always get the correct answer. Okay, so 100 into 0.082. And what is the temperature? Already given 300. And power is 1. Why? Because we have calculated delta Ng is 1. And that is how you can calculate the value of Kp, everyone. Kc was given to you. Kp they have asked you to calculate. The only thing that you have done in this entire question is you have solved for delta Ng. Rest everything was directly given to you in the question. And how we have calculated delta Ng? Total number of gaseous moles on the product side minus total number of gaseous moles on the reactant side. Do we have to include something which is pure solid or pure liquid? No. Please ignore anything that is in pure solid or pure liquid state. They are not counted in your equilibrium expression also and in the calculation of delta Ng as well. Okay, so this is how we can calculate it. So now I hope we can solve it. We are not going to do the entire solution. We have seen how to substitute the values, which formula to use. Now it is up to you to cross check the answer. Okay, see the next question. At equilibrium, for this reaction, the concentration of A2, B2 and AB are, okay, it is given to us. Let's write them. A2, the concentration is 1.5 into 10 to the power minus 3 molar. Capital M is written for molar. It means moles per liter. Okay, so you can write it like this also. Molarity, capital M. What is the unit of molarity? Mole per liter. So you can either write mole per liter or you write capital M. It means the same thing. So don't get confused. What is this capital M? It is the unit of concentration. Okay. Great. A2, B2, 2.1 into 10 to the power minus 3. And we have AB, 1.4 into 10 to the power minus 3. Okay, great. Now you have to calculate the, what will be the Kp, see, Kp for the decomposition of AB at same temperature. Okay, you understand how to calculate the equilibrium constant. You substituted the correct value also, but you have not read the question completely. They are not talking about formation of AB. They are talking about decomposition of AB. So you have to reverse the expression. Don't substitute it directly. Don't do the wrong calculations. Okay. So you will write it like this. 2AB so for this expression, if the value was Kp, okay, so for this one, Kp dash, it will be 1 over Kp, right? If you reverse the expression, what happens to your equilibrium constant? You take the reciprocal of the equilibrium constant. What if you multiply your equation by some number? That will become the power of your equilibrium constant. What if you divide the equation by some number? Again, if you divide it by that number, that will become the power, 1 by 2, 1 by 3 and so on. So if you multiply your expression by something, that becomes the power. If you reverse the expression, you have to take the ratio. As simple as that. You have to take the reciprocal. Now can we substitute the values? Yes, you can do that. Okay. So Kp dash is 1 over Kp. So you can directly calculate the Kp and then take the reciprocal, or you can substitute the reverse values. Up to you how you want to proceed. So I am just going to calculate the Kp, reversing it, your task. Okay. So I will write it here. Okay, you will substitute the values. This is Kp. You are trying to calculate Kp dash. Okay, substitute the values, find out the correct answer. That is all you have to do. Okay, now, and why we are doing the reversal? I hope we understand that, because they are asking you the Kp for the decomposition of AB. They are asking about decomposition of AB, not formation of AB. That is why we are taking the reciprocal. If they ask you about the value of Kp for this expression, then solve it directly, calculate the Kp. That would have been your final answer. But right now, we are talking about decomposition. That is why we have taken the reciprocal, not because we are feeling like it. Okay, it was given to us in the question itself. Alright, see the next question. 15 moles of H2 and 5.2 moles of I2 are mixed and allowed to attain equilibrium at 773 Kelvin. At equilibrium, the number of moles of Hi is found to be 10. The equilibrium constant for the dissociation of Hi is. Again, let's write the expression, then we will talk about the dissociation part. Okay, so this could be your expression, H2. Right? This is the expression. H2 plus I2 gives us 2Hi. Okay. What is given to us in the question? In the beginning, 15 moles, 5.2 moles. Okay. So this is at time t equal to 0. Try to understand this now. Okay. And in the beginning, obviously, I don't have any Hi because I have just mixed them. Okay. H2 plus I2, this was given to us in the beginning. How many moles? 15 moles of H2, 5.2 moles of I2. I mix them and then I will get the product Hi. So at time t equal to 0, when we have taken them, there is no Hi. After some time, your reactants will react and some product will get formed. How much we don't know. Let's write the expression at least. Okay. So let's say at time t equal to equilibrium, some of the reactant has reacted and some of the product has been formed. Okay. So let's say X moles are consumed for H2. X moles are consumed for I2. Why am I writing X? Because 1 mole of H2 reacts with 1 mole of I2. So if X moles of H2 have been consumed, X moles of I2 also would have been consumed. Follow the stoichiometric coefficient. Okay. One more thing. If 1 mole of H2 gives you 2 moles of Hi, and if I am saying X moles are reacting, how many moles of Hi will be produced? If 1 mole gives you 2, X moles will give you 2X. First of all, try to understand this. This is important. After that, they can give you any value. you should know how to write this expression. I will repeat it once again. Okay. First of all, you have written the expression H2 plus I2 gives you 2Hi. Done. We know about that because they have given us hydrogen iodine and it gives us hydrogen iodide. Okay, great. Then we have taken initial number of moles again given to us in the question also. 15 moles, 5.2 moles given to us. I have not taken it deliberately. Great. Then I have said that as the reaction will proceed, reactants will react, so their concentration, the number of moles will decrease. Products, their concentration will increase, their number of moles will increase. Great. Then I see the expression. I can see 1 mole of hydrogen reacts with 1 mole of iodine to give you 2 moles of Hi. We can see that in the expression, the balanced chemical equation, I can see that. Okay. So if I am saying X moles are reacting, so for I2 also X moles will react, 1:1 ratio. So how many moles of Hi will get formed? Twice. Why? Because 1 mole of H2 reacts with 1 mole of I2 to give you 2 moles of Hi. Okay. This part is done. Now, how to calculate the value of X? See, they have given you one information in the question. Read the question now. At equilibrium, the number of moles of Hi is found to be 10. They have told you in the question itself that at equilibrium, these many moles of Hi were found. So, they have given you the value of 2x. They have helped you. That is how you will come to the correct expression. Otherwise, how will we find the value of X if they don't give us the experimental data? Okay. So, they have given us the value of 2x. So, if 2x is 10, then X will be 5, right? Obviously. Okay. So, you can write these many moles are present at equilibrium, and for them 15 minus 5, 10 moles, 5.2 minus 5.2. So this is the equilibrium number of moles of hydrogen. These are equilibrium number of moles of iodine, and these are equilibrium number of moles of Hi. So in the expression for Kc, we have to write concentration, but we have written number of moles and no issues. How to convert number of moles into concentration? Divide them by volume. Simple. Okay. So if I want to represent the concentration of H2, I will write number of moles 10 over volume. We don't know. Let's write V. It will cancel out. You don't have to worry. Okay. Equilibrium concentration of I2. This is at equilibrium. Okay. This you have calculated. 0.2. And what about Hi? Given to us 10. Okay. So now you have the equilibrium concentration of H2, I2 and Hi. Now can we calculate the value of Kc? Yes, you can. Okay. See, this V will cancel out, right? So do we have to substitute the value of volume? No, not required. It will cancel out. Just substitute it in the equation. Okay. So in the expression, this is left. Is this a final answer? No. Why not? This is Kc. We were trying to calculate the value of Kc only. No. In the question, they have asked you about the equilibrium constant for the dissociation of Hi, not formation of Hi. You have calculated it for the formation of Hi. So what should we do? Take the reciprocal, everyone. That will be your final answer. Okay, so please don't leave the answer at 50. Okay. See, they have tried to confuse you by giving you that as an option. So if you are in a hurry, you will think, oh, I have calculated the value of equilibrium constant. I substituted the values. I've calculated it correctly. You have, but you are not doing the complete calculation. You have left the question midway. You are not reading the last statement. They are talking about dissociation. So you have to take the value of reciprocal of the equilibrium constant that you have calculated, Kc dash, because they are talking about dissociation, not formation of Hi. So that was the last step that you have to remember. Rest everything obviously you have solved correctly. Okay. So I hope it is making sense. I hope we understand now 50 is not the correct answer. you are not reading the question completely. So read it, whether they are talking about association or dissociation, whether they are asking you about the expression given or they are asking you to reverse it and then tell the answer. So anytime you calculate any equilibrium constant, and if they have asked you to reverse it, then take the reciprocal of original equilibrium constant. That will be your answer. Okay, so I hope this is making sense. I hope this is clear. Let's see the next question. At temperature T Kelvin, the equilibrium constant for the following two reactions are given. Okay, so they have given you the equilibrium constant for the first expression 16, for the second expression 25. What is the value of equilibrium constant for the reaction given below? Okay, so what are we doing here? In the first expression, they have taken only A. So I have to divide my first expression by 2. I hope this is okay, right? In the final equation, I have A. In my original expression, I have 2A. So we are dividing the first equation by 2. Okay, I will write it. If I divide the first equation by 2, divide by 2, or multiply by 1 by 2, your choice, how you want to write it. So what will be the value of equilibrium constant for this expression? For this one, it is 16. If I multiply it by some number, it will become the power, right? So for this particular expression that I have written, the value of equilibrium constant will be 16 raised to the power 1 by 2. Okay, so for this, let's write it as K1 dash. It is 16 raised to the power 1 by 2. Whatever you multiply your equation with, that will become the power of equilibrium constant. So I have multiplied it by 1 by 2, that will become the power. Okay, first part done. What else? Now they have asked you to add it to the second equation, and in the second equation also you have to divide it by 2. Okay, I will give you the final expression. We are doing the correct thing. See, in the final expression they have written D gas, but in the equation given here it is 2D. So obviously I have to divide it by 2. Okay, so if I divide this expression also by 2, it will look like this. 2V gas So what is the value of equilibrium constant for this one? Again, 25 raised to the power 1 by 2. Let's call it K2 dash. So this will become 4. This will become 5. Is the equation done? No, equation is still not done. Now what are we doing next? So this will become, if I simplify it, this is the expression that you have written now, A gas giving you half B gas, half C gas. And for this, the equilibrium constant you have calculated as 4. Okay. Now, this is the expression B plus half C gas, D gas. And for this, the equilibrium constant you have calculated as 5. Okay. Now, by using these two equations, you have to somehow make this equation. What should we do then? A gas I need. If I add these two equations, will I get the final answer? You will. Okay, see, if I subtract half B from B, I will get half B on the reactant side. This half C and half C will cancel out. So what would be left? So what should I do? I should add these two expressions together. So if I call this as equation A, let's not call it equation A because you will get confused with this one. Let's call this as equation 4. Let's call this as equation 5. So if you add equation 4 plus 5, you will get the final expression. And if you add two equations together, what will happen to their equilibrium constant? Their equilibrium constants will be multiplied. Okay, so I will write it. A gas, half B gas. D gas You add them together. This will cancel out. Okay. Or should I write the final equilibrium constant for this one? This will be my final answer. Okay. So if you multiply your equation by some number, that will become the power of equilibrium constant. If you add two equations together, what will happen to their equilibrium constant? Multiply the equilibrium constant. What if I subtract one equation from another? Then take the ratio of equilibrium constant. As simple as that. What if I reverse the expression? You will take the reciprocal. Already done. Okay. So this is how you solve for this equation. This will be your correct answer. That is how you proceed here. Okay, see the next question. At 1000 Kelvin, the value of Kc for the below reaction is 10 mole per liter. What is the value of Kp? You have done this question already, right? Same thing. Kp is equal to Kc into RT raised to the power delta Ng. What is delta Ng? 2 minus 1, 1. Okay, same thing. So Kc is 10.082. Temperature also given 1000. And you can calculate the value of Kp. See, again, a similar question was asked in 2023 also. So they are asking you similar kind of question. If you know the expression, you are getting max. So obviously, please write these formulas down and revise them again and again and again. Then only you can remember them in the examination. If you don't revise them and you are thinking, yes, I can do this thing in the examination itself, I will remember it. No, you will not if you have not revised it properly. So write the formulas in one single sheet for this chapter, then revise them again and again. And like that you can do for all the other chapters of physical chemistry also, and for organic chemistry obviously write all the formulas. Alright, for the name reactions, please focus on them. Oxidizing agent, reducing agents, focus on them, and then only you can score good marks. Okay, see the next question. At temperature T Kelvin, the equilibrium constant for the reaction A gas, okay, this is the expression given. I will write it here. Okay, this is the expression given. Leave this here. If the reaction takes place in this form, okay, they have multiplied it by 2. Takes place in the following form. Its equilibrium constant is Kc dash. What is the correct relationship between Kc and Kc dash? Okay, so they are saying for this expression, equilibrium constant is Kc. For this expression, equilibrium constant is Kc dash. What is the relationship between Kc and Kc dash? Now you are proficient in this thing. If I multiply my equation by some number, that will become the power of equilibrium constant. So what should I write? My Kc dash raised to the power 2. That's all I am doing. Okay, so which one matches with that? Kc dash is Kc square. This one is matching. Okay, such a simple question. If you know that if I multiply my equation by some number, that will become the power of equilibrium constant. That's all I am doing here. Okay, see the next question. Kp over Kc for this reaction at temperature T Kelvin is, again, what are we doing? Kp is equal to Kc, RT raised to the power delta Ng. We are using that same expression. Nothing fancy, same thing. Okay, so I can write it as so what is the value of delta Ng? Number of gaseous moles on the product side minus total number of gaseous moles on the reactant side. You just have to subtract them. Okay, so total number of gaseous moles on the product side 1. Total number of gaseous moles on the reactant side 3 by 2, right? So delta Ng is correct. That will become the power. So this will be my correct answer. Alright, so this is another way in which they can ask you the relationship between Kp and Kc. We are doing the exact same thing. We are not doing something different. Okay, see the next question. Observe the following equilibrium. Fe3 plus reacts with thiocyanate to give you this particular complex. This is a question on Le Chatelier's principle. Now understand what are we going to do here. Okay, so this is some equilibrium that was already established. You try to disturb it. Okay, so what you have done to create that disturbance, you have added aqueous oxalic acid solution. Now what is this oxalic acid solution going to do to our equilibrium expression? Your oxalic acid solution will release oxalate ion in solution. These oxalate ions will react with your Fe3 plus ions and they will form a complex. How will that How will that disturb our equilibrium? If Fe3 plus ions react with oxalate ions, their concentration will decrease, right? So what is the disturbance you have created? You have decreased the concentration of reactants. This is your observation. Okay, so they will form a complex. As a result, concentration of Fe3 plus ions decreases. Concentration of reactants decreases. And if you decrease the reactant concentration, how will the reaction respond? Reaction will try to increase it. How will the reaction increase the concentration of reactants? By going in backward direction. This is what you have learned, right? You create the disturbance, reaction system will respond in opposite manner. You decrease it, reaction will increase it. How will it increase the reactant concentration? By producing more and more reactant. How can we do that? By going in backward direction. So your reaction is proceeding in backward direction. But is that given in the options? No. They have asked you something tricky. They're asking you, if reaction goes backward, what are the changes you will see? So if I go in backward direction, this deep red color will start disappearing, right? Which color you will see prominently? I will see yellow color of Fe3 plus ions. This deep red color will start disappearing because I am going in backward direction. If I go in forward direction, deep red color will appear. Okay, so what should be the correct answer? Since we are going in backward direction, deep red color will start disappearing. The reaction shifts towards the formation of this complex. No, this means we are going in forward direction. We are not. Deep red color increases. Again, this also means we are going in forward direction. We are not. Intensity of deep red color decreases. Yes, this is your correct answer. Deep red color starts disappearing. Deep red color intensity decreases. Why? Because we are going in forward, we are going in backward direction. Okay, so this is the correct answer. There is definitely some change in equilibrium because we have disturbed it by decreasing the concentration of reactants. Okay, so this is how they will ask you the questions based on Le Chatelier's principle. Okay, see the next thing. Last question. Observe the following equilibrium. Which one of the following does not disturb it? Addition of H2, you are increasing the concentration of reactant. Obviously, it will disturb it. If you increase the concentration of reactant, reaction will try to decrease it, will move forward. So this will definitely disturb it, not the correct answer. Removal of HI, if you have removed the product, reaction will try to form it. Again, it will proceed in forward direction. Definitely, it will disturb the equilibrium. Addition of I2, again, you have increased the concentration of reactants, reaction will try to decrease it, will go in forward direction. This will also disturb your equilibrium. Addition of helium, inert gas. Addition of inert gas at constant volume will not affect your equilibrium. It will remain undisturbed. Okay, so that was your question, right? Which of the following does not disturb the equilibrium? Addition of inert gas will not disturb it. Okay, so that is all for today. Let me see if you have asked any questions. Let me see if you have any doubts. Good afternoon, everyone. Hasini, there is no such thing as not so important for EAPCET. Okay, the priority order changes, but yes, you have to learn everything. Maybe it is not as in that much amount of weightage. That does not mean it is not at all important and you can just leave it. You have to read everything, give some more importance to some chapter, give less importance to other chapters, but don't leave it entirely. Okay? Alright, Hasini. Does this cover ionic as well? Yes, we are covering the entire equilibrium, right? Chemical, ionic, both. I have considered the content for both of them. I have added the questions for both of them. You will get the PDF in our Telegram channel. You can go through the rest of the questions, practice more. Okay, but I have covered the entire content. Alright? Blue giraffe. Yes, Ganesh, you can definitely score 30 plus marks, but you have to practice more questions. Obviously, you have to revise the concepts. Whatever questions I am doing here, whatever concepts I am telling you, you have to do more and more questions based on that. Okay, so if you are thinking I will just attempt these many questions and I will not revise it afterwards, that will not work. Okay, you have to practice some more, but yes, the content is enough to secure 30 plus marks for sure. Okay. Harshit, same thing, right? Yes, Harshit, we add the all the other questions that I have not solved in this session. I have added that to the PDF itself. Okay, so you can easily practice more questions based on it. And please take up any past year questions, last 5 years, practice them. That will work. Okay, so past 5 years question, revise the content, solve the questions, and obviously you will score good marks. Okay. At least 3 are watching, right, Sheikh? Okay, more will watch after the session. Maybe they don't have the time for the live class. It works for me. At least someone is getting the benefit. Alright, everyone. So that is all from my side. Okay, I want to give you one more information and then we will end the session. Alright. So I just wanted to tell you about our Maths 1-year program. So if you have brothers and sisters who are studying in grade 3 to 10, they can take help of this course. All IIT and NIT teachers will be teaching it. It is a 1-year course at just ₹999. So you will cover your entire CBSE, ICSE and state board syllabus here, and you can download our app through the scan code, and you can take help of Sysya AI as well. You can ask your doubts. There is text-to-text doubt solving, speech-to-text doubt solving, and image-to-text doubt solving also available here. So please enroll and tell others also. The course will start from 5th May and our EAPCET series will continue. Okay, so we will talk about hydrogen and S block elements in the next class. So be prepared for it, revise it, and if you have any doubts, you can ask me in the comment box. The PDF of this entire session will be uploaded in the description box, and you can also download it from our Telegram channel. So please follow it. Okay, so that is all from my side. Have a great day and all the best for your examination. Bye everyone.